Hello everybody, welcome into another lesson. So today we are going to talk about the ratio of areas of similar figures. So far in this course we have covered earlier in the area of plane figure segments, which we've been on. We talked about the area congruence postulate, which states that if two figures are congruent, then their areas are congruent. Well, today we're dealing with similar figures. A little earlier in the course, not terribly long ago, we talked about similar figures, especially similar triangles, but it works for any polygon in general. Similar polygons, if you recall, have a scale factor of similarity for their sides. And this theorem states that if the scale factor of two similar figures is a to b, so some arbitrary numbers a to b, then part one is the ratio of the perimeters is a to b. We've covered that, but of course the perimeter is just the sum of all the sides added together, so the ratio would still be a to b. But what's new here is in part two is that the ratio of the areas is a squared to b squared. The reason for that is because the area is always in square units. That's why you would square your scale factors, because the area is in square units. And this is not going to be a very long lesson. We're just going to do a few examples here, and then we'll be done with this lesson here. So let's see. So we got the scale factor for two similar figures is 1 to 4. Okay. So we have, for this first exercise, we have the scale factor for two similar figures is 1 to 4. We want to find ratio of the perimeters and then find the ratio of the areas. So if the scale factor is 1 to 4 for the figures in general, the ratio of perimeters is also 1 to 4. So I'm going to abbreviate it ratio of lowercase p, standing for perimeters. The ratio of the perimeters is also going to be 1 to 4. Now to find the ratio of the areas, which will be ratio of capital A, that's going to be 1 squared to 4 squared, which then, of course, you do the exponents, that ratio would actually end up being 1 to 16 for the areas. So the ratio for the perimeters is still 1 to 4, like for the original scale factor, but the ratio of the areas would end up being 1 to 16. And I got more. Let's see, this time we're going to have the ratio of two similar figures is going to be 3 to 2. So the ratio of two similar figures for the next two figures are 3 to 2. We want to find the ratio of the perimeter, find the ratio of the areas. So as we know, the ratio of the perimeter is the exact same as the scale factor itself. So the ratio of the perimeter is also going to be 3 to 2. Now, where it gets fun is when you try to find the ratio of the areas. Ratio of capital A. That, of course, would be 3 squared to 2 squared. And then when you do the exponents, that ratio would turn into 9 to 4. So the ratio of the perimeters is still 3 to 2 like the scale factor, but the ratio of the areas ends up being 9 to 4 because of the square units. Alright, a little bit of algebra with this one. The ratio of two similar figures is going to be x to 2y. So the ratio of two similar figures for this one is going to be x to 2y for the scale factors. Find the ratio of the perimeters and the areas. Well, again, the ratio of the perimeter, or the perimeters I should say, is just the same as the scale factor. That's x to 2y. Now we're going to find the ratio of the areas, which, as we know, the ratio of the areas is each part of the scale factor squared. So that would be x squared to the quantity of 2y squared, which would simplify into x squared itself to 4y squared. So the ratio of the perimeters in this case is still the scale factor, x to 2y, but the ratio of the areas ends up being x squared to 4y squared. Alright, a little bit different here. A little bit different problem. I used the wrong side. Okay. This time they give that the ratio of perimeters for two similar for two similar figures is 9 to 5. This time we need to find the scale factor itself and the area. So you got two similar figures that the ratio of their perimeters is 9 to 5. We need to find the scale factor, then the ratio of the areas. Well, we don't start out right off the bat knowing the scale factor, but we know that the ratio of their perimeters is 9 to 5. Well, isn't it true that the scale factor and the ratio of the scale factors and the perimeters are the exact same? So that means the scale factor itself would also be 9 to 5. As a ratio of 9 to 5 for the scale factor. Now that we know the scale factor, we can find the ratio of the areas. So to find the ratio of the areas, you'll take each part of the scale factor squared. So you'll take 9 squared to 5 squared, which would simplify into 81 to 25. So the ratio of the areas ends up being 81 to 25. I have just four more, and then we're done. Alright, so we have two similar figures where the ratio of their perimeters is 3 to 13. We need to find the scale factor itself and the ratio of the areas. Well, if the ratio of the perimeters is 3 to 13, that means the scale factor is also 3 to 13. Alright. That was pretty easy. Now we need to find the ratio of the areas. The ratio of the areas is your scale factor squared. So the ratio of the areas would equal 3 squared to 13 squared, which would equal 9 to 169. But does 9 to 169 simplify any further? We have to find that out. Let's see. Nope, it doesn't. It doesn't simplify any further, but it's always good to check, because to find a true scale factor, you want to have it in simplest form. So the scale factor itself is 3 to 13. The ratio of the areas ends up being 9 to 169. Quite a wide spread there. All right. This is about to change up yet again. Three more problems, then we're done. So for these next two similar figures, they start you off right away with the ratio of the areas. The ratio of the areas for two similar figures is 25 to 1. We need to find the scale factor and the ratio of the perimeter. Well, it definitely would help if we found our scale factor first, right? What do we know about scale factor and ratio of areas? That the ratio of areas is your scale factor squared, right? So the scale factor itself, if you want to work backwards from the ratio of the areas and find the scale factor, that's going to be equal to this positive square root of that 25 to the positive square root of 1, which square root of 25 is 1, square root of 1 is 5. So that leaves you with the scale factor itself of 5 to 1. Now what about the ratio of the perimeters? The ratio of the perimeters is the same as your scale factor. So the ratio of the perimeters in this case is also 5 to 1. And these are good for scale models, like if you're trying to, I don't know, reconstruct Buckingham Palace from Legos or something. You're definitely not going to build Buckingham Palace itself in your house. It'd be bigger than your house. You're going to use a scalar model. That's where the scale factors and ratios come into handy, where they apply. Okay. Two more problems, then we're done. Okay, so the ratio of areas of two similar figures this time is going to be 9 to 64. So the ratio of the areas of two similar figures is 9 to 64. We need to find the scale factor and the ratio of the perimeters. Well, since we have the area, to find the scale factor, we got to work backwards. We have to take the square roots of both parts of the scale factor, so that would be the square root of 9 to the square root of 64, which would simply give you 3 to 8. So the scale factor of these two similar figures would end up being 3 to 8, which also means the ratio of your perimeter in this case is going to be 3 to 8. All right. And I got one more problem, then we're done. I told you this wouldn't be a very long lesson. It's a pretty simple lesson, honestly. It really is. All right, last one. Now, this is different. The ratio of areas is 2 to 1. That's going to screw with some people a little bit. The ratio of areas is 2 to 1. That 2 to 1 almost looks like it should be a scale factor, doesn't it? But it's not. They tell you the ratio of the areas for two similar figures is 2 to 1. So we need to find, of course, the scale factor and the ratio of the perimeters. Well, the scale factor, of course, to find that, you take the square roots of the ratios of your areas. So the scale factor is going to be equal to the square root of 2 to the square root of 1. Well, square root of 2 doesn't simplify any further, but the square root of 1 becomes just 1. So your scale factor is going to be the square root of 2 to 1. That would be your scale factor for the two similar figures, a square root of 2 to 1. Which, since you're also asked to find the ratio of the perimeter, it's always the same as your scale factor, so the ratio of the perimeter is also going to be equal to the square root of 2 to 1. And that's really it. Now, when we move into 3D objects, like into objects in space and finding surface areas, lateral areas, volumes, stuff like that, we're going to have a similar lesson for scale factors involving those too. But that segues into my next point, that we're done with the areas of plane figures. Next lesson, we're going to start areas, surface areas and volumes of solids. We're going to start moving into 3D objects. The very next lesson will be real easy. We're just going to talk about cubes in the next lesson. How to find the surface area of a cube and how to find the volume of a cube. So I hope everybody has a great night. Happy Thanksgiving. Take care.